Hi everyone, welcome back to part 2 of physics class this morning. Just to go through the solution there from question 2 that you were just doing, we had two different thermometric properties that were measured. So the first one was a change in resistance in terms of ohms when temperature was changing, and the second one was a change in length of a column of mercury when temperature was changing. So you needed to plot two separate graphs here, and you were looking for the temperature at somewhere in between the two fixed points there in terms of the data it gave you in the table. So the resistance there in ohms, we knew it was 11 ohms in ice. So your first fixed point was at 0 degrees, it was 11 ohms, and we knew it measured 14.3 ohms in steam. So your second fixed point there at 100 degrees was 14.3 ohms. You then join those 2 points with a line, and if the thermometer was placed in a liquid at unknown temperature somewhere in the middle, we knew that the resistance was measuring 12 ohms in that case. So you had to find 12 ohms on your resistance axis, come up, see where it cut the graph, and then come across to read the temperature. So at a resistance of 12 ohms, the temperature was measuring approximately 29 degrees Celsius. Same type of method for the second thermometric property, the length of the column. We had the two fixed points. At 0 degrees, it measured 40 centimeters. At 100 degrees, it measured 240 centimeters, and the unknown temperature in the middle, it was measuring a length of 100 centimeters. So from your graph there, you find the 100 centimeter length, come up, see where it cuts your line, and then again come across to read the temperature scale. And approximately 30 degrees there at 100 centimeters. They should be different if your graphs are fairly accurate. They should be slightly different for the two different properties, because they only agree at the two fixed points of 0 and 100, but in general they will disagree at other temperatures in between, because thermometric properties do not change proportionally. They vary differently. When we were doing the experiment last week in the lab, the girls called me over and said, "Miss, our length of the two thermometers, the mercury and the alcohol, aren't going or changing at the same rate." And I said, "Good, they're not supposed to." So they're not supposed to agree at those values in between. So there should be a difference in readings between thermometers. Two different types of thermometers should give different readings at the same temperature, because what we say is that different thermometric properties do not change proportionally with the same degree of hotness. So if we measured for example here, two different thermometric properties, the resistance of a coil of wire being one property, and we measured the length of a column of liquid being the other thermometric property, somewhere in between they are not going to exactly match up, and that is expected. So here we're just showing two graphs. If we had those two thermometric properties, which is very similar to the question you did there a minute ago, if we plotted resistance versus temperature, and we plotted the length of the column versus temperature, somewhere in the middle there, they are going to slightly disagree. So in the same beaker of water, the resistance One might measure 19.5 degrees Celsius, whereas the length of the column might measure 20.5 degrees Celsius. So slightly different. They do not change proportionally. So this next slide here is important, what we call disagreement between thermometers. Two different thermometers based on two different thermometric properties are graduated at the ice point and steam point, and a Celsius scale is created for each. So typical questions here that come up in an exam are the three following here. Will those two thermometers agree with each other when measuring temperature? To explain your answer. Number 2 then is why we have a standard thermometer, why is it necessary? And number 3 is what is that standard? So which thermometer is usually used as a school lab standard thermometer? So question 1 there, will they agree with each other when measuring temperature? They will agree at the two fixed points, 0 degrees Celsius and 100 degrees Celsius. In general, they will not agree at other temperatures in between. And the reason why here in bold is how you would answer this in an exam. They will not agree because different thermometric properties vary differently with changing temperature. Question 2 then, why is it necessary to have a standard thermometer? Links to this concept again, because different thermometers have different thermometric properties and give different readings at the same temperature. And then question 3, very often asked as well, is what type of thermometer is used as a school lab standard? That is our mercury and glass thermometer. That is the one we used in our experiment last week. So if the supervising teacher, please, this morning can pause the presentation here at this slide for a few minutes and allow students to note the points in this slide. This whole slide is important. So pause please and let the students note this whole slide. Alright, so folks, the mandatory experiment in this chapter is the one we did last week, to plot the calibration curve of a thermometer using the lab mercury thermometer as a standard. So we did this with a mercury thermometer and a alcohol thermometer, both changing the length of the column of liquid. Another way we can do it, and this could come up in an exam, is using the mercury thermometer as your standard and the EMF of a thermocouple as the second thermometer here, the thermometric property here being that changing voltage or that changing EMF. So it would be the same type of experiment where you would measure at increases in temperature the increases in voltage, in this case very, very small millivolts, and you would plot your two fixed points, 0 degrees, 100 degrees, and all of those points in between. Now, this is slightly different to the length of the column because this type of graph would start at the origin. So at 0 degrees Celsius, there would be 0 volts or 0 millivolts of EMF. So it would start at the origin, slightly different. I'm not going to talk through the process. It's the same process, increasing from that fixed point of 0 in steps all the way up to the fixed point of 100. And instead of measuring length of the column like we did, we're measuring the change in the voltage on the voltmeter. Same process otherwise. So that procedure and precautions and so on are there in the slideshow. If you want to have a read of that in your own time, it's there for you. This is the one we did then, and this is commonly the one you would answer in an exam question because you're familiar with it. where we have the graduated mercury thermometer versus the ungraduated alcohol thermometer, measuring those two fixed points at 0 degrees in ice, measure the length of the column at 100 degrees in steam, measuring again the length of the column and plotting all those points in between. We went up kind of in steps of 10 degrees each time. So the difference here is your graph does not start at the origin of 0, it starts at some length. So when you started off at 0, there was a length of liquid in that column. So for example, if that was 30 millimeters, that was your starting point there on the y-axis of your graph. So again there, the precautions and so on are there if you want to look back on them in your own time. That's the one we did last week anyway, in the lab. Alright, so we are nearly there. I'm going to just briefly talk through a chapter checklist. The standard unit for measuring temperature is Kelvin, not degrees Celsius. Degrees Celsius is our common practical everyday scale, but in physics your standard unit now is the Kelvin. So you have to be able to convert from degrees Celsius into Kelvin and vice versa. So that formula there is in your log tables under the heat section, so knowing where that is and being able to do a conversion. You need to be able to define temperature, what is temperature and what is its unit. You need to know the difference between heat versus temperature, heat being a form of energy, whereas temperature being a measure of hotness and coldness. The relationship between the two scales, Celsius and Kelvin, and you need to know the 6 different thermometric properties. So what are they? Are you able to describe an example of them and how they're measured? And you need to know then what a thermometer is, what it does, and the concept of the disagreement between two different thermometric properties in terms of thermometers. One mandatory experiment in that chapter, so plotting the calibration curve, and if you have a question like you practiced here in the first class, having those 2 fixed points and some unknown in between, can you do that? And can you find that temperature for the unknown in the middle using a graph? All right. So down the bottom there, the chapter is the symbols for the quantities we introduced, the standard units and the symbols for those units as well. So there is the chapter checklist again. One last thing there at the end of that list is everyday practical thermometers. So can you name then, for example, your clinical thermometer to measure body temperature? Do you have a couple of examples of how they're used? A cooking thermometer to measure the temperature of food. Things like that. What are the everyday practical uses of the thermometers? Knowing some of them. Alright folks, quiz time. So you're working in pairs, or if you don't have someone next to you, turn around to who's behind you or who's in front of you and work as a group of 3. You're quizzing each other here to come up with these. So I'm going to give about 1 to 2 minutes for each section. So the first section here, I'm going to ask you 5 questions. And can you come up with the answers between the 2 or 3 of you? Question 1. What is meant by temperature? Define temperature. Question 2. What is the unit of temperature? Question 3. What is the difference between heat and temperature? Question 4. What are the 2 fixed points on the Celsius scale? And question 5. name 2 scales that are used to measure temperature. So 2 minutes. Those first 5 questions, can you answer them? All right, class, your 2 minutes are up. So let's look at the answers for those 5 questions. See how many of you will get 5 out of 5. Temperature of an object is a measure of the hotness or coldness of an object or body. Have to mention hotness or coldness. Standard unit for temperature is your Kelvin, capital K. Difference between heat and temperature. Heat is a form of energy, whereas temperature is a measure of hotness or coldness. The 2 fixed points are the melting point and the boiling point of water, or you could have said 0 degrees or 100 degrees Celsius also. And the 2 scales used to measure temperature are your Celsius scale and Kelvin scale. All right. Section 2, folks, there are 6 questions in it, and you have a few calculations to do here in this section. So again, I'm going to call them out here and give ye 2 minutes between the 2 or 3 of you there. Can ye get the answers? Question 1, give the equation that defines temperature on the Celsius scale. Question 2, what is the boiling point of water on the Celsius scale? Question 3, the SI unit is named in honour of Lord Kelvin. What is the temperature of the boiling point of water in kelvins? Question 4, the temperature of a body is 300 Kelvin. What is its temperature in degrees Celsius? Question 5, the temperature of a body is 34 degrees Celsius. What is its temperature in Kelvin? And question 6, if the temperature of an object is 28 degrees Celsius, what is its temperature in Kelvin? 2 minutes, go for it. Alright class, your 2 minutes is up. Let's have a look. How many will we get out of these 6 questions? So your equation there defining temperature on the Celsius scale is temperature in degrees Celsius is the temperature in Kelvin minus 273, or more technically 273.15. What is the boiling point of water on the Celsius scale? On the Celsius scale it is 100 degrees Celsius. The standard unit is named in honour of Lord Kelvin. What is the temperature of the boiling point of water in Kelvin? So 273.15 plus 100, 373.15 kelvins. Question 4 there, you had to convert from kelvins to Celsius. So 300 Kelvin minus 273. 27 degrees. Some of you might have included the 0.15. And then you had to convert from degrees Celsius into Kelvin. So adding that 273, or being more precise, adding 273.15. You should have gotten there 307.15 Kelvin and 301.15 Kelvin. So a lot of maths there in a quick couple of minutes. Last section here in the quiz, we have 6 questions again. So moving back into a bit of theory here. Question 1, explain the term thermometric property. Question 2, name the thermometric property used in a mercury thermometer. Question 3, what is the thermometric property of a thermocouple? Question 4, name a thermometric property other than EMF. Question 5, name one other type of thermometer and state its thermometric property. And question 6, explain why it is necessary to have a standard thermometer. Again, in your groups, pairs or threes there, 2 minutes, go for it. Alright folks, 2 minutes up. So last 6 questions, let's have a look. A thermometric property is a property that changes measurably with temperature. The thermometric property used in a mercury thermometer is the length of the column of liquid. Thermometric property of a thermocouple is EMF. Name any other thermometric property you could have used, any of them. Length, pressure at a constant volume, volume at a constant pressure, resistance or colour. And then name another type of thermometer and state its thermometric property. So if you were naming, for example, a thermistor, its thermometric property would be resistance. A thermocouple, its thermometric property would be EMF, or liquid crystal, the thermometric property would be colour. Finally then, two different types of thermometer will give slightly different readings at the same temperature, or their thermometric properties will vary differently. Tells us why it's necessary to have a standard thermometer. Alright folks, that is bringing us to the end of chapter 14, and I'm going to leave one question with you for homework. It's very similar to the question 2 you did earlier, where you have two different thermometric properties. You have 3 points, the two fixed points of 0 and 100, some unknown in between, and you're graphing the changes in values versus the temperature. So one graph, you're going to have the length of the column versus temperature. Second graph, you're going to have the change of resistance versus temperature, and you're using that graph by connecting the two fixed points to find the temperature at the unknown value in the middle. So exact same question there as you practiced earlier. I'm going to leave it with you for homework, and we'll have a look through the solution for that tomorrow morning. Alright folks, thank you, have a good day.